This is Algebra 2, Lesson 8.4, Expected Value. So the expected value of a situation is simplified by calling it the average outcome. So if I was going to repeat an experiment multiple times and then take the average of all of those outcomes, that would be the expected value. And we are going to calculate this. There is a formula that is read the sum of the probability of an outcome. I'm going to put something in front of that. The outcome multiplied by the probability of the outcome. And so we need all of the possible outcomes. We need the probability of each of those outcomes. We need to multiply those outcomes with their probabilities, and then we need to add them all together. I put some tables on this worksheet that's going to do all of those steps for you. So 1, list the outcomes. 2, find the probabilities. 3, multiply each of those. And lastly, add them up. So the table you can see on example A has the top row where we can list all the possibilities, the middle row where we can list all the probabilities, and then the bottom row where we can multiply each of those, and then finally the sum to add them up. Example A reads, when Nate goes to visit his grandfather always gives him 1 bill from his wallet. Nate peeks in the wallet beforehand and sees 8 bills. 2 1s, 3 5s, 2 10s, and 1 20. What is the expected value of the bill Nate will receive? So the top row is for listing our outcomes, our possibilities. So the question now is, what could Nate possibly get? There are 4 options. That's why I have 4 spaces in the table. He could either get a $1 bill. He could get a $5 bill. He could get a $10 bill, or he could get a $20 bill. Sadly, Nate will not be getting a 50 or 100 today. Probabilities. P of X is for probabilities. So what is the chance of him getting a $1 bill? If we see that there are 2 $1 bills out of the 8 bills altogether, the probability would be 2 out of 8. We can decimal this if you'd rather. 2 divided by 8 is 0.25, but I'm going to go with fraction on this one. What is the chance of getting a $5 bill? There are 3 5s out of the 8 bills, so 3 out of 8. Again, you could fraction that into a decimal, 0.375, but I'm going to stick with a fraction. And how many 10s? There are 2 10s out of the 8 bills altogether. And how many 20s? There is 1 20 out of the 8 bills altogether. So we listed the outcomes. He could get a 1, 5, a 10, or a 20. We listed the probabilities, 2/8, 3/8, 2/8, 1/8. And next we're going to multiply. And that will be straight down 1 times 2/8. I think I'm going to decimal this. So 1 times 2/8. If you're not sure on how to multiply your fractions, you can just do 1 times 2 divided by 8. And that would be 0.25. Same deal, 5 times 3 divided by 8. 5 times 3 divided by 8. 1.875. 10 times 2 divided by 8. 2.5. And I know that this is going to be the exact same answer because 10 times 2 is 20. 20 over 8, 2.5. 20 times 1 is also 20 over 8, 2.5. And the last step is to add all the numbers in the bottom row. So I see that as 5. 2.5 and 2.5 is 5. Plus 1.875 plus a quarter. And it looks like the average outcome is $7.12.5. Now, obviously, he's not going to get a $7.12.5 bill because that doesn't exist. But if we picked one, put it back, picked one, put it back, picked one, put it back, we repeated this experiment a bunch of times, the average would be about $7. Letter B, a fair 6-sided die is rolled If the number showing is even, you lose a point for each dot showing. If the number showing is odd, you win a point for each dot showing. Find the expected value of one roll. So first we need the possible outcomes. What could you possibly get? How many points could you get? So if you roll a 1 and it says you would win because it's an odd, I could either win 1 point. Or if I rolled a 2, if it's an even, I would lose. I would get -2. Or I could win 3, or I could lose 4, or win 5, or lose 6. That's my possible outcomes based on every roll of the die. Next, it asks for the probability of each outcome. Well, on a standard die, you have a 1 out of 6 chance for rolling any side of the die. Next, we need to multiply. And if you forget, this is telling us we take our outcome, that's the number on top, we multiply it by our probability, that's the number in the middle, so 1 times a sixth. I think I'm going to go decimal on this one again. I think I like going decimal because it's usually easier to add decimals than it is to add the fractions. They all have common denominators, so it wouldn't be that hard, but I'm going to go decimal. So -2 times 1/6. Is that 0.3333333333? And it'd be a -0.333. I'm going to keep 3 decimals since I had 3 on the first one. A +3 times 1 divided by 6, that's 0.5. A -4 times 1/6, that would be a -0.66666, but I'll round it to 0.667. 5/6, who's that? 83333333333. And the last one would be -6/6. That's easy, -1. And the last step is to add these all together. So I'm going to start with -1 plus 0.833 minus 0.667 plus 0.5 minus 0.333 plus 0.167 brings me to -0.5. So the expected value from one roll is that I would lose half a point. If I were to play this game 10 times, multiply by 10, and I would be expected to lose 5 points. That is it for these notes. Good luck on the exercises, and please let me know if you have any questions.